Okay, so in this system, you want to solve the system by substitution, and so with substitution, you want to pick one of these equations and obtain the variable and solve for one of the variables. Now, usually, it makes things a lot easier if the coefficient of one of the variables was 1. In this case, it's not. And if you take this coefficient here, -5, divide both sides by -5, you would end up with fractions. The same thing here. If you solve for y, you'd end up with fractions. Over here, solve for x, you would end up with fractions. Over here, solve for y, you end up with fractions. So regardless of which one you pick, you're going to have fractions involved. So it doesn't matter in this case which equation you choose, just pick an equation and go for it. Now, what I would do is see these coefficients here are negative, and if I look at this equation, this coefficient is positive. I would go ahead and solve for this variable here in the second equation because, the reason is some students, when they solve for or when they divide both sides of an equation by -5, they tend to sometimes mess up with the signs in that situation. So I would just go ahead and solve for the variable x since this coefficient is positive. So I'm going to go ahead and solve for this equation for x. First I'm going to go ahead and rewrite this. And I'm going to go ahead and get 2x by itself, so I'm going to add 7y to both sides. And so when I do that, I combine like terms, I get 2x equals 7y minus 17. That's what I get. All right, now to get x by itself, I'm going to have to divide both sides by 2, just like this. Which you do one side, do the other. And when I reduce, I get x equals, now I'm going to go ahead and rewrite this as two separate fractions. And so when I do that, I'm going to get 7y divided by 2 minus 17 divided by 2. So that's what I get. So I have some fractions involved here. Now remember, the next step is to take this expression right here, and in place of x, as that's what x equals, in place of x, you're going to go to the other equation, and you're going to substitute that expression. So I get this now. I get -5 times 7y divided by 2 minus 17 divided by 2, and then minus 8y is equal to 17. So I have this linear equation with just one variable in it, the variable y, so I need to solve for y. It just so happens in this case, I'm involving some fractions. All right, so let's distribute. -5 times 7y divided by 2 is a -35 halves y, so -35y divided by 2. A -5 times a -17, let's see, 17 times 5 is a positive 85 halves. That's what I get. Minus 8y equal 17. So that's what I have. So -35, when I distribute the -5, I get -5 times 7y is a -35 halves. And -5 times a -17 is a positive 85 halves. All right, now let's combine like terms. Okay, so I'm looking at this term and this term. So just go ahead and use your calculator. It's a lot quicker to use your calculator. So I have -35 divided by 2. So -35 divided by 2 minus 8. And when I do that, I get this. I get -25 halves. Well, remember, -25 halves is right here. -25.5 is equal to a -25 and a half. That's what that is. And so if I convert that back to a mixed number, to an improper fraction, I get 25 times 2 is 50. 50 plus 1 is 51. So I get a -51 halves. So that's what this becomes right here. So this becomes -51 halves y plus 85 halves equals 17. All right, now I got to get y by itself, so I'm going to go ahead and subtract 85 halves from both sides, just like this. And so combining like terms, I get -51 divided by 2y equals, now on your calculator, say 17, subtract 85 divided by 2. And when I do that, I get -25 halves, -25.5 again, which I already figured out is this improper fraction. So that's going to equal -51 divided by 2. Now to get y by itself, I want you to notice something. To get y by itself, I'm going to go ahead and divide both sides by this coefficient. So I'm going to divide both sides by negative 51 halves, negative 51 halves. But I want you to notice something. When I divide both sides by negative 51 halves divided by negative 51 halves is 1. 1 times y is y. And this fraction being divided by this fraction, they're the same thing. So this fraction divided by itself is also 1. So I found the solution, the y coordinate of my solution. Okay, now remember to find the x coordinate. Let's go back to this equation here where I already solved for x. Now remember, I could have easily messed up around here. So in the end, you want to go back and check your solution to make sure it actually works. Okay, so let's go back to this one. So here's what I get. So I'm going to go back to this one where x equals 7y divided by 2, that's a y, minus 17 divided by 2. All right, so in place of y, I'm going to substitute 1. So I get 7 times 1 divided by 2 minus 17 divided by 2. Well, 7 times 1 is 7. So 7 divided by 2 minus 17 divided by 2. And let's just use your calculator. Well, actually, you don't have to. The denominators are the same, so just subtract their numerators. 7 minus 17 is a negative 10 divided by 2, which is a negative 5. So I found the x coordinate of my solution. So my solution, it looks like, I got to check it, is negative 5, 1. All right, now, again, I said you got to check it only for the reason that I could have messed up anywhere along the process. So let's just verify that this works. All right, so x is negative 5, y is 1. So you're going to go back to the original equation. And so where we see the variable x, you can check each equation. Where we see the variable x, you're going to substitute negative 5. And where we see the variable y, you're going to substitute 1. So let's check. All right, so remember, we have negative 5 times x is negative 5, minus 8 times y is 1, and I want to see if that's going to equal 17. So all I'm doing is going back here, and where we see the variable x, I substitute negative 5, and in place of y, I'm substituting 1. All right, so let's see what we get. We get negative 5 times negative 5 is a positive 25. Negative 8 times 1 is a negative 8, and the question is 25 minus 8 equal to 17? And the answer is yes. All right, now let's check the other one. The other equation was this. 2x minus 7y equal negative 17. So let's check it. All right, so I get 2 times x is negative 5, minus 7 times y is 1, and I want to see if that's going to equal negative 17. Well, 2 times negative 5 is a negative 10, negative 7 times 1 is a negative 7, and negative 10 minus 7 is equal to negative 17. So I found my solution. So this is the solution. Okay, number 2, we had this. All right, number 2, we had this system. 6x plus 10y equal 4, 3x plus 5y equal 12. All right, now again, the coefficients are not 1, so and regardless of which one you solve for, you're going to end up with fractions. Divide both sides by 6, you have fractions. Divide both sides by 10, you have fractions over here. Divide both sides by 3, you end up with fractions. Divide both sides by 5, you end up with fractions. So it does not matter which equation you choose. Just pick an equation and choose and solve for one of the variables. So if you want to go to this equation here, that's fine. So this equation, and let's just go ahead and solve for x in this case. So I get 3x equal 12. Now remember, you got to be careful with what you're doing here. So if you're going to solve, if you're going to get this term by itself, you're really subtracting 5y from both sides. So this becomes 3x equals 12 minus 5y. That's what that becomes. All right, now you're going to get x by itself. So I'm going to go ahead and divide both sides by 3, just like this. 3 divided by 3 is 1. So I get x equal. Now remember, go ahead and rewrite this as two separate fractions. 12 divided by 3 is 4 minus, and then this becomes 5/3 y. All right. Now the next step, remember, is to take this expression that you solve for x, this expression here, and in the other equation, in place of x, you're going to substitute 4 minus 5/3 y. So I get this. I get 6 times this expression, 4 minus 5/3 y, because that's what x equals, plus 10y equal 4. All right, now distributing, I get 24 minus, all right, now let's think about this right here. I have 6 times 5/3. 6 times 5/3. Remember, if you gotta remember how to multiply fractions. So if you write this as 6/1, you can multiply first and then reduce, or you can reduce first and then multiply. If I reduce first, 3 into 3 is 1, 3 into 6 is 2. I get 2 times 5 is 10, and that's what this becomes here, 10y. So 6 times a negative 5/3 y is a negative 10y. Plus 10y equal 4. All right, now notice what happens in this case. What happens is that when I combine like terms over here, I get that the y's cancel out, so I get 24 equal 4. And so notice there's the y is no longer there. So what that means, and notice 24 equal 4 is a false solution. I mean, is a false equation. It's not a true statement. So that means that there's no solution. So this equation has no solution, or this system has no solution. So you would say solution, no solution. Okay? So the variables y canceled out, and you get 24 equal 4, which is a false statement, so there's no solution. Okay, now what that means is that if you were to graph this, and you graphed this in a previous lesson, if you were to graph this, these two lines would be parallel. They do not intersect. That's what that means. The lines do not intersect. Okay, so they're parallel. All right, so that was number 2. Now let's look at number 3. Let's do another one with fractions in it. Okay, so in this system, again, let's do this by substitution. Notice it's not going to matter which equation you choose. So I'm just going to go ahead to the first equation, since this term has a positive coefficient, all the others are negative, and just go ahead and solve for x. You'd have to divide both sides by 2. So let's go ahead and do that. You could have gone to any one of those. It does not matter. Now, some of you may go ahead and pick the second equation and solve for y, but be careful. You're going to be dividing by -2. So let's just go ahead and do that. Let's go to the second equation and solve for y. So I get negative. Let me go ahead and write this over. I get negative 5x minus 2y equals 6. So if I'm going to solve for the y, for the variable y, I'm going to have to add 5x to both sides, just like this. And so I get when I combine like terms, I get negative 2y equals 6 plus 5x, and then divide both sides by -2. So what I was saying was this: if you solve for any of these other terms here, and you'll be dividing by a coefficient that's negative, so you got to be careful. So this becomes y equals 6 divided by -2 is a -3, and then a positive 5x divided by 2 is a -5/2 x. That's what you get. Okay, nothing wrong with that. Just be careful. Your signs you can't mess up with any part of this. All right, you take this expression here now, and you go to the other equation, and in place of y, you're going to substitute this. All right, so I get 2x minus 3 times y, which is this, and then equal -8. All right, so I'm going to go ahead and distribute now, and so I get 2x, a -3 times a -3 is a positive 9, a -3 times a -5/2, that's what I have, a -3 times a -5/2, a negative times negative is a positive, so this becomes a positive 15/2. That's what this becomes. So there's going to be a plus 15/2 x, and that's going to equal -8. Okay, combining like terms, use your calculator if you need to. 2x plus 15/2 x. So let's see what that is. 2 plus 15 divided by 2 equals, I get 9.5. So let's think about what 9.5 is now. 9.5 means 9.5. And 9.5, 9 times 2 is 18. 18 plus 1 is 19, is 19 halves. So I'm going to go ahead and rewrite 2x plus 15 halves x as 19 halves x. Okay? Plus 9 equal negative 8. Okay, now the next step is to subtract 9 from both sides. And when I do that and combine like terms, I get 19 halves x equal a negative 8, and a negative 9 is a negative 17. And then finally, let's go ahead and divide by x. I'm sorry, solve for x. I'm going to divide both sides by 19 halves, just like this. Now you got to remember something from a previous course, though. 19 halves divided by itself is 1. 1 times x is x. But here's what you got to remember. You're dividing fractions, so you got to change that to a multiplication problem. So this becomes a negative 17 times the reciprocal of 19 halves. So that's 2 over 19. And so that becomes a negative 17 times 2 is a negative 34 divided by 19. All right, now don't change that to a fraction. Leave it as, I'm sorry, don't change that to a decimal. Leave it as a fraction. Because this decimal, if you look at it, you have a negative 34 divided by 19. I mean, it's just a, it's not a terminating decimal. So you get all these digits. You don't want to estimate. You don't want to round off because you want an exact answer. So leave it as a fraction. Now the problem is that you have your x coordinates a fraction. It's no big deal. You have access to a calculator. Use it. All right. So let's go back over here now and solve for y. So in place of x, I'm going to substitute this fraction. So I get y equals negative 3 minus 2 halves times a negative 34 over 19. That's what I get. Oops, sorry. Y equals negative 3 minus 5 halves x. So negative 3 minus 5 halves times x, which is a negative 34 19ths. So I get y equals negative 3. Now remember, a negative times negative is a positive, so we can plus, and now 5. Remember, when multiplying fractions, see these two fractions, multiply the numerators together, multiply the denominators together. So 5 times 34 is 170, and then 2 times 19 is 38. So that's what I get. Okay, now on your calculator, figure out what that is. Negative 3 plus 170 divided by 38. Use your calculator. Negative 3 plus 170 divided by 38 equals, and I get this. All right, now what I would do at this point, your calculator has the ability to go from decimal to fraction. So let's do that. All right, now I'm going to go to do that. I'm going to go from on my calculator. See this button right here? I'm going to have to use that. So I'm going to go second, and then oops, sorry, PRB. See this PRB right here, fraction decimal? I'm going to use that. Sorry. So this, and then press equal, and notice what I have is this mixed number. So this becomes 1 and 9/18. That's what that becomes. So now I'm going to change that. I can leave it like this if I want to, or I can change it back to a mixed number, to an improper fraction. Does not matter. So I'm going to just go ahead and leave it like this. But if you want to change it back to an improper fraction, you have to say 18 times 1 is 18, and 18 plus 9 is 27. So I got 27 over 18. All right. Now I want you to notice also, you see where I had that 9, I'm sorry, that's 19, excuse me, 19. So 19 times 1 is 19, and 19 plus 9 is 28 over 19. All right, so my solutions are, your solution is going to be x is negative 34 19ths, comma, 28 over 19 for y. Or if you want to write these as mixed numbers, you can. 34 divided by 19, so 19 into 34. Say 1 times 19 is 19. 34 minus 19 gives us 15. So this becomes negative 1 and 15 19ths. y would be 1, which we already had here, 1 and 9/19. All right, so that is my solution. Now you got to check this. Now, see how messy this became? I could have easily messed up anywhere along the way. Now you need to check your solution to make sure it's actually correct. I would go back to the original and use these improper fractions. I would not use the mixed numbers. I'd use these. So let's do that. Now you got to be careful. So here's what you're going to do. You got to be careful with this. See, the first equation was 2x minus 3y equal -8. And the second equation is -5x minus 2y equals 6. And I want to check and see if this solution is correct. And my solution I want to check is -34/19 and 28/19. So I could have easily messed up anywhere along the process. All right, let's check it. What I would do first is I would substitute these values into the variables. So 2 times -34/19 minus 3 times and y is 28/19. And I want to check and see if that's equal to -8. You have access to a calculator. Just use your calculator. Look at what I'm doing. I'm saying this. 2 times -34 divided by 19 minus 3, times 28 divided by 19, and then press equal, and hopefully it's equal to -8. And it is. So that's true. Now let's go to this one. -5 times x, which is -34/19, minus 2 times y, which is 28/19, just like this, and you want to see if that's going to equal 6. Use your calculator. You have access to a calculator. So -5 times -34 divided by 19 minus 2 times 28 divided by 19. Hopefully that's equal to 6. Now let's press equal, and notice it is 6. So that's correct. So this is my solution. I did not mess up anywhere along the way. If I would have messed up anywhere along the way, whatever I would have gotten here would not have satisfied both equations at the same time. Okay? All right, so that is a review of solving a system by substitution that involves fractions.